Hello and welcome everyone to the third out of 5 webinars hosted by Hong Kong as part of our Race to Zero webinar series, Uniting Asia to Combat Climate Change. My name is Jasper Hilkhuizen and I am from the Arup Hong Kong office. Today we focus on the theme of Towards Clean Energy, and as mentioned yesterday during the session on decarbonizing the built environment, while the reduction of energy use is important, the transition to producing and using clean energy is arguably even more crucial. We are thrilled to have yet again an excellent panel today, consisting out of renowned leaders from the energy sector that are all leading the way in the transition to clean energy. Today's discussion will be moderated by Mr. Edmund Leung, past president of the Hong Kong Institute of Engineers and the founding chairman of the Hong Kong branch of the Institution of Mechanical Engineers. Please feel free to post any questions and comments in the chat box during the event, as at the end there's time reserved to address questions from the audience. Now, without further ado, Mr. Leung, over to you.
Hello, everyone. Thank you, Jasper. In line with COP26, the Environmental Bureau of Hong Kong has set some ambitious environmental targets for Hong Kong. As the majority of energy production will be electricity by our power utilities, it is natural that the focus would be on the fuel mix for power generation. Presently, power generation accounts for about 66% of our total energy production. The new target includes the retirement of all coal-fired generation plants by 2035. Also, by that time, renewable energy should account for about 7.5% to 10%, with the remainder mainly from natural gas and nuclear plants. On the demand side, the target would be 15% saving in energy use in buildings, as buildings account for about 90% of all electric power consumption in Hong Kong. These targets obviously pose serious challenges to the Hong Kong public utilities, as they are already producing power with state-of-the-art technology, helping Hong Kong to reduce carbon emission to curb our ever-increasing carbon footprint, apart from other emittents. This is to enable us to enjoy blue sky for most part of the year. As for large-scale application of renewable energy, the government estimate of 10 years ago believed that even if we cover all the land areas in Hong Kong with solar cells, the total energy generated would be less than 5% of the total electric power generation capacity, which amounts to about 10,000 megawatts. Technology advances in the last decade could have increased the power density of solar cells, but it will still be a very long way ahead, even including wind farms, to achieve a 10% portion of renewable energy to our total power generation. With limited potential for solar and wind power within the confines of Hong Kong, we will need some innovative means to approach this ambitious target. However, Hong Kong is an outward-looking city, and our power utilities, apart from continuously seeking best technology and promoting effective energy savings for consumers, have also asked their expertise to apply the expertise to overseas projects that they own and operate, and will seek cooperation with our mainland counterparts. With determination, the ability to meet these ambitious targets may be achievable. Today, we have the top management of all of our public utilities on this panel, and I look forward to hearing their grand plans to lead Hong Kong to this blue sky future for Hong Kong, to achieve the target of 2035 carbon neutrality by 2050. Please let me introduce our panel speakers in the order of their presentation. And I'll start with Mr. T.K. Chiang, Managing Director of CLP. Mr. Chiang has overall responsibility for all of CLP's regulated business, which includes a vertically integrated electricity utilities serving customers in Kowloon, the New Territories, and Lantau Islands. In other words, apart from the Hong Kong Island itself. I would introduce everyone briefly, and then I would ask Mr. T.K. Chiang to do his presentation. After T.K. Chiang, the next speaker will be Mr. Charles Tsai. Charles is the Executive Director of Power Asset Holding, which means that he's on the board and he's the Chief Executive Officer of Power Asset starting from January 2014. He has been in the group since 1987, and he's been a director, alternate director of most of the subsidiaries, including those overseas. He has a bachelor degree in mechanical engineering and is a registered professional engineer and a chartered engineer. So here you are, Charles. Mr. Alfred Chen is managing director of Town Gas. He's also chairman and executive director of the company since March 2007. He's also vice chairman of Shenzhen Gas Corporation Limited and Foran Engineering Group Company Limited. He was also previously a non-executive director of the 10th session of the board of directors of Shanghai Dazhong Public Utilities Group, all of which are listed public companies. And I would move on to introduce Mr. Peter Thompson. Peter is Director in East Asia Energy Business Leader of Arup. He has over 35 years of experience in management, design, and implementation of energy infrastructure projects across a number of Asian countries to facilitate the transition towards clean forms of energy generation and reduction in demand through the implementation of energy efficient solutions. So ladies and gentlemen, here you are. We have 4 prominent speakers. And I'll start with TK, if I may. Please start your presentation.
Thank you, Edmund. First of all, I'd like to express my heartfelt thanks to the organizers to give me the opportunity today to share with the audience about our thinking on how to achieve the carbon reduction target set by the Hong Kong government. Now, a little bit of background. I think all of us are fully aware that actually, climate change is an imminent issue, and the urgency of coming up with carbon reduction initiative is already at the doorstep. So and also our country, the mainland China also set the what we call the 2 carbon targets to have carbon emission peak in 2030 and also achieve carbon neutrality before 2060. Now, I think this is a very important backdrop. A lot of people may not fully aware the importance of this. Now, first of all, the time between the carbon peaking to the carbon neutrality is only 30 years, which is a very, very short period of time as compared with other countries. You may know that other countries take a few more decades in order to achieve that. Secondly, it's because of this stringent target. In order for Hong Kong to achieve carbon neutrality, we are also competing with other provinces and cities in the mainland. I'll come to that later on. Now, for Hong Kong, we have already had the carbon reduction target in the medium term, to 2030 in terms of carbon intensity, 65 to 70%, and then 2050, carbon neutral. So we look at the medium-term achievement. Of course, for the 2030, it's yet to be seen, but that has been set, in the previous Carbon Action Plan 2030 plus issued by the government in 2017. And based on the information that we collected, because of the strategy of switching from coal to gas in the power sector in Hong Kong, we have already achieved quite a significant amount of reduction in carbon for the whole Hong Kong. If you look at this chart, just the power sector actually contributed to more than 20% reduction in the absolute tonnage of carbon emission in last year. And even with that, actually our supply reliability as well as our tariff is also still maintained at a very competitive level. Now, how do we achieve that? Is by means of adding our gas generation unit, supplementing with more energy supply in order to ensure gas supply security, enhance our interconnection with the mainland China, to take more zero carbon energy from the mainland, and also explore renewable energy development in Hong Kong. But that's only part of the story, because it only addressed the medium-term target by 2030. Going beyond that, with the Hong Kong government climate action plan just published this month, you can see that actually we are taking a series of steps in order to achieve this carbon neutrality by 2050. Now, as I said, because power sector is I would say the major or the quite important sector in order to help Hong Kong to achieve that, we'll continue in the medium term to continue to replace coal with gas so as to quickly reduce our carbon intensity. But at the same time, we'll also try our best to develop as much renewable energy as possible in Hong Kong by various means, including we have the feed-in tariff scheme so as to encourage our customer to install rooftop solars, to maximize the renewable energy development in Hong Kong. We'll also facilitate the connection of all the other more relatively larger scale of renewable energy, including waste to energy. For example, the incinerator now being built. At the same time, we are also exploring the offshore wind farm, as I mentioned. But that only can help Hong Kong probably to achieve less than 10% of the renewable energy as explained by the government in the climate action plan. In order to achieve carbon neutrality, then definitely we need to have more zero carbon energy, and we have to rely on regional cooperation. And then going to the end, longer term, we probably need to explore more zero carbon fuel, including green hydrogen, in order to achieve that. Now, apart from Hong Kong, for CLP as a group, we also issue our revised climate vision, and we also set a target to achieve net zero by 2050. So we keep revising our target and keep tightening our target every 5 years, and also set different interim target. We have already achieved 0.6 kilogram of carbon dioxide per unit of electricity, and then going forward, we have set targets by 2030, 2040, and then achieving carbon zero by 2050. So I hope that this will give people a feel about the overall plan, and I look forward to the subsequent discussion going forward. But most important, I think, is that everybody have to act together in order to achieve the common goal to achieve this carbon neutrality. Thank you.
Thank you, TK. That was great. The next speaker will be Charles. Charles, when you're ready.
Thank you very much, Edmund. Thank you. Thank you very much, Edmund. First of all, I'd like to thank the organizer for giving me the chance to share our slides today. My name is Charles Tsai from Power Asset Holdings. Power Asset Holdings is actually, we're an energy infrastructure holding companies. We have 22 investments in 8 countries spanning 4 continents. Majority of our revenue is derived from regulated businesses, and that's the distribution of electricity and distribution of gas. The lion's share of this distribution network is actually in UK and Australia, and therefore my slides will mostly focus on these 2 countries as to what we're doing to meet the climate change challenge. We have in gross megawatt 10 gigawatts of electricity generation. Of the generation, what we're doing very much right now is focusing our attention, converting all our coal to gas plants, transitional fuel. We're expanding our renewable energy, battery storage, waste to energy portfolio, as well as continuing on with our carbon capture and utilization installations. In the electricity network, because of the massive influx of distributed energy, in terms of solar, in terms of wind, as well as in terms of EVs, what we are doing now is modernizing, digitizing our network so that we can get down from the grid level all the way down to the demand side, people's home, in order to meet the challenge. In the gas network, what we're doing is blending natural gas. With the natural gas, we're blending 20% of hydrogen into our system at the moment, as well as with the ultimate goal of converting them up to 100%. So we're repurposing all our natural gas network. And finally, we're trying to produce, or we are now trying to produce green hydrogen from electrolyzer to blend into our system. If you look at our distribution network from an electricity standpoint, in UK, we're distributing probably to about 30% of UK's population on electricity. In gas, we're distributing to about 25% of UK's population, and it is around the same scale for Australia. In power generation, if you look at our fuel mix, if we look at just coal and gas generation, in 2016, we're about 53% coal. By 2023, we will be 24% coal. By 2033, we will be 0% coal generation. And that's how aggressively we are cutting everything down. If you look at power distribution in South Australia, as an example of the challenge that we're meeting, a third of the houses have their solar panel on their roof. This is about 280,000 solar panels, generators, and about 20,000 battery installation installed in people's home. On October 11th, 2020, if you look at the system demand is actually hitting almost zero. In fact, the whole of South Australia is supported by solar. And that is really the challenge that we're meeting right now. 50% or roughly half of our zone substation are running in reverse power flow. What we're doing now with the government is that we're implementing time of use network tariff so that we can shift the consumption, not to midnight, but more towards midday to utilize maximum amount of solar. We're also working on VPP, virtual power plants, 500 megawatts of VPPs with the government in order to stabilize the grid. So the grid's resilience, the grid's inertia is a major challenge for us right now. In the UK, we're anticipating a large amount of renewable, a large amount of EVs, hybrids, heat pumps, etc. What we're doing is 4 different projects. You're welcome to look at UK Power Network's website to understand them better. The first one is on the grid level, active response. What we're doing is mashing zone substations together so we can channel available capacity from one zone substation to another zone substation in real time. Constellation is a project that we're working on a zone substation level, basically to channel, again, more electricity, more capacity. Phase shift is balancing the 3 phases inside one zone substation to maximize the supply that we can give. And Core 4 Grid is a project that we're working on in a domestic level so as to meet the demand of excess solar generation, excess battery, excess EV. On the gas side, what we're doing, in UK, we're running 2 projects. The first one is a 20% blending of hydrogen. Keele University, we've already finished that project very successfully. We've blended 20% of hydrogen right into the entire university campus. The second project we're working on is Winladen. This is a project that will finish by first quarter next year. By that time, we will be able to blend hydrogen into the existing gas network on a commercial scale. The third project we're working on in UK is 100% hydrogen replacement. And if you look at that picture there, you will see a hydrogen appliances being installed inside a test home. In Australia, we are running we're blending 20% hydrogen, 5% hydrogen, utilizing an electrolyzer. So we're utilizing the daytime excess solar, nighttime excess wind, converting them into hydrogen and blending it into the system. And we are aggressively working on the next project, which is a 10 megawatt electrolyzer, and we're hoping to blend that 10% of the hydrogen, green hydrogen created by this project into the system. And that's what we're doing on the gas side. So thank you very much. I'll pass it on.
Thank you, Charles. Our next speaker will be Mr. Alfred Chen, Managing Director of Hong Kong and China Gas Company Limited.
Thank you, Edmund, and good day, everybody. Very pleased to be here to talk about the net zero carbon. Many people in Hong Kong knows that the Hong Kong and China Gas, or Town Gas, deliver gaseous fuel to homes and businesses in Hong Kong. But not many people know that the company has actually a much bigger scale of operation in mainland China. In Hong Kong, we have roughly about 2 million customer accounts. In China, we have 40 million customer accounts, so it's 20 times. In fact, as far as natural gas is concerned, over the past 20 years, we deliver and a lot of natural gas on a yearly basis. Up to last year, our annual delivery of gas is 38 billion cubic meters. So it's roughly about 10% of the entire China city gas consumption. We have 126 kilometers of gas pipeline, so it's actually a very big operation. Over the past 20 years, we helped China to transform from using coal gas or LPG into a much cleaner gaseous fuel, which is natural gas. And we help China in this way to clean up the air, PM 2.5, exit rains, and so on, and give back a lot of China's cities the blue sky and the white cloud. And they are very happy about the achievement so far. But we should not stop at this particular point. Now, going back to Hong Kong, you can see that this company has a long-term history, 160 years in 2022. And 160 years ago, we used coal and for the entire century. And then in the 1960s, we start to use fuel oil to replace coal, and then naphtha, and then natural gas. And very recently, we also use landfill gas, although the percentage of landfill gas use is not very big. It's only a couple of percentages. But today, we have been using this fuel, natural gas, particularly landfill gas, naphtha, to make town gas, which consists of almost half of its composition of hydrogen and 29% methane gas. So it's very, very clean at the user point. Now then, going to this 2030, 2060, and particularly in China, this particular goal, our company has got a lot of plans and strategies to achieve that for China as a whole. First, we look at the renewables. And renewables, we can roughly divide it into solar, wind, and then power storage. And then hydro, municipal waste usage, biomass, tidal and wave, and geothermal. And we look at our strength within the company. We have selected 3 major areas, that is solar, wind, plus power storage, municipal waste, and biomass. And then also we'll develop the roadmap into a hydrogen economy, which is considered as the ultimate fuel of the future. Now, this is our plan. You are seeing that we have in the middle is natural gas, which is the cleanest fossil fuel compared with coal and oil. Okay, we'll continue to deliver that to the customers and expanding the customer base as well as to replace coal furnaces, power generation with natural gas. So this will continue. Then on the left-hand side, we have the smart energy, which is basically use solar, particularly the rooftop solar on large-scale factories or storage areas where you have a lot of surface area for mounting the solar panels. Then we have the smart energy will consist of energy internet, energy efficiency management, and so-called the zero carbon zones, which I will describe a bit later. And then also hydrogen utilization. Then on your right-hand side, we have the biomass platform. We use agricultural waste to produce advanced biofuels, biochemicals, biomaterials, and also the production of green hydrogen. At the bottom, we use the urban waste, which is kitchen waste treatment, produce natural gas from it, sewage treatment, recycling of usable materials, metals, glasses, and so on, and incineration. Now, just to talk about some of the targets, for example, on the smart energy side, by the 2025, the target for us is to develop 200 zones within different cities in China where we will dedicate a lot of renewables to be used, including hydrogen, including solar panels, and so on. As far as the solar panels concerned, our target is 15 gigawatt PV panels installed, by which we will be able to reduce carbon emissions by 11 million tons of carbon dioxide each year. On the biomass platform, we have 3 areas. One is to use the biogrease. For example, is use the cooking oil, and also some of the waste grease from the palm plantation, and also the related industries, to make advanced biofuels for blending into diesel and also in the aviation fuel. So that is a kind of the future fuel to use the existing internal combustion engine and also air engines. We have biochemicals and biomaterials, because using wind or solar, you can produce electricity energy, but you cannot produce materials which still today use a lot of fossil fuels. And then ultimately, we have the green hydrogen production from agricultural waste, which we have already been successful in the R&D stage. Basically, this is our plan. Thank you very much.
Thank you, Alfred. Our last but not least speaker is Mr. Peter Thompson from Arup. So, Peter, when you're ready.
Yeah, thank you, Edmund, and a pleasure to be here today to hopefully explain to you the context of Hong Kong and why we don't have, or the technical challenges involved in including renewables in the energy mix for this particular country. Okay, so the title of my presentation is The Hong Kong Transition Towards Clean Energy, and it's really looking at the technical challenges and opportunities. Just a bit of background. I won't dwell on this too much. I think most of you are familiar with Hong Kong, but just the highlights are that it's a very densely populated country. But in terms of its land area, it's actually quite small. It's only got around 1,000 kilometres squared of land and about 1,600 kilometres squared of sea. And then when you take into account the mountainous areas and the country parks, the usable area is only about a half of each of those. So it's actually quite small, and the opportunity therefore to develop renewables is also quite small. And also the generating capacity is something that needs to be looked at. I mean, at the moment, the generating capacity is around 10 gigawatts, and by 2050, we're expecting that to increase to around 18 gigawatts. So there's quite a high demand of power for this country per capita. Just looking at the fuel mix as it was in 2015, just to show the advances made. Back 6 years ago, the predominance was coal and natural gas, with a bit of nuclear thrown in from both HKIE and CLP. But you can see over the last 6 years that transition has occurred, where we've replaced coal quite significantly with natural gas from both companies. And this is really the natural progression that one would expect for Hong Kong. It does need mass power, and therefore the only way that you can replace coal realistically is with natural gas, which is a much cleaner fuel, as was mentioned before. But the interesting point is the amount of renewables in the mix is only 1% at the moment, and I'll try to explain why that is the case. And it's fairly easy. It's really a function of sort of the geography, the power demand for the country, and also the price. It's only over the last 6 years that the cost of renewables has really come down to a competitive price, where it's now competitive with the likes of coal-powered power generation, and that's really sort of fueled the transition in many countries towards renewables. So I just look very quickly at many of the sort of typical renewables that one could consider for Hong Kong. That would include solar, PV, onshore wind, offshore wind, waste to energy, tidal, and wave energy. These have all been mentioned previously. I'll just go through them very quickly. We look at solar in the first instance, although solar is sort of announced as being a great solution, and it is, the problem we have in Hong Kong is a lack of space, and really the only places we can place solar is on the top of buildings. So we've done a quick calculation, working out what we believe would be the available area on buildings if we were to put solar panels on every single rooftop using current technology, assuming that the average sun hours per day is limited to around 3 to 3.5, which is typical for this location, then really the amount of solar power that you could get with that many solar panels is around 568 to 1,000 megawatts. And to put that into context, that's only around 5 to 8% of the present demand. If we're talking about 2050 demand, it's actually quite a bit less, so sort of 3 to 5%. So although it's a great solution, it doesn't really offer the solution to replace the fossil fuel power that we have at the moment. Onshore, offshore wind, I'm a really strong advocate, particularly of offshore wind. It's something that's being developed in places like Japan and Korea and Taiwan. Hong Kong is not in such a fortuitous situation. We're obviously based on closer to the equator. We don't have a Pacific coastline. And therefore, if you actually look at the available area for the development of onshore wind, it's limited to around 3 to 5% of the current demand. And if you look at offshore wind, it's about double, so it's about 1,400 to 2,400. So again, that's only 12 to 20%, and that's if you put wind farms absolutely everywhere. And I think there will be some public objections and such like to go against that. And then of course you've got tidal and wave, and again this comes down to the fact that Hong Kong's situated on the equator. We only have a very small tidal range as a consequence, so really tidal energy is not really an efficient solution. And similarly with wave energy, it's not an area that has significant waves, which is why we don't have too many surfers in this location. So the opportunities for waste to energy as well is another one that was considered. So you've got the sort of municipal waste. Obviously it's a big problem in Hong Kong, good to get rid of it. But again, looking at the calculations, it only amounts to around 4% of the existing total energy consumption. And if you look at integrated waste, it's only around 1%. So if you do the maths, you can add them together. You're really only looking at renewables ever if you did maximum renewables everywhere of less than 20%. And I think that's why the target from the government is set at around 7.5%. So we have to look at it slightly differently, and this is a strategy being adopted by the government and others, including the utilities, and that's to work on building and network efficiency. So it's looking at district energy, energy storage, smart energy systems, building in the integrated renewables into the buildings to make as much use as possible of those renewables, and also that sort of passive and active demand, building energy storage and such like into the system to reduce that demand. Because of every megawatt produced, that actually reduces to half a megawatt at the other end when it's actually used. And of course, just lastly, is another area that everyone's touched upon, and it's something that's our company in particular is focused on, and that is moving towards the hydrogen economy. We do see hydrogen as really being the solution worldwide, particularly for countries that don't have too much of a renewable resource, which is Hong Kong is one of those. So we have a map here that shows how the integration of hydrogen should develop within a city environment. So it would be a mixture of molecules of hydrogen converted to electrons and vice versa, in order to provide a more fuel efficient city. So the hydrogen economy, I believe, will be the solution for Hong Kong ultimately, and that is the direction that both CLP and Hong Kong Electric and Town Gas are all moving towards. So just to look at briefly, just to finish, what the solution is for the transition. Obviously, coal to natural gas is something that's going on at the moment. Even though renewables aren't necessarily so influential in terms of the overall energy mix, we should always encourage renewables. And as the technology improves, then obviously those percentages that I mentioned before will increase. Demand side is obviously a big part, which I just mentioned. So all stages 1, 2, and 3 are in operation at this time. But step 4 and 5 is what we should be aiming towards. So it's more electrification, more electric vehicles, more electric transportation systems, electrification of our homes and such like, in order to minimize the amount of fossil fuels that we use. And then lastly, the last step is the use of hydrogen and biofuels, which, as I mentioned, has been touched upon by all of the speakers. And it's really just a matter of time. At the moment, hydrogen is not that competitive when you compare it cost-wise against coal. But I do have faith in places like China, looking at that technology, bringing those prices down to a point where it actually does become a competitive solution. So that's it for me. Hopefully that provides some insight into why Hong Kong doesn't have so many renewables. Thank you.
Thank you, Peter, and thank you all speakers. So that completes the introduction from them. The exciting part now comes. This is the Q&A session, and I would like to invite audience to pose questions to us. And I saw a question from the audience, but I'm going to leave that for TK to answer. Let me start with Peter yourself. Peter, I would regard you as an authority in clean energy in this region, and I'm not boasting. And I'd like to ask you to elaborate on your presentation. The Hong Kong Climate Action Plan sets targets for Hong Kong, and these are very ambitious targets, as I said in my introduction. Would you see a larger potential in energy saving and carbon reduction in the supplies or in the demand side in Hong Kong? In particular, this target says we need to achieve 20 to 40% reduction in residential and commercial buildings. Can you give us your wise views on how you see this could be achieved or not achieved?
Yeah, sure. Yeah, thank you very much for your endorsement there. In terms of the carbon reduction, I think that's really comes on the supply side. So really the carbon reduction is a function of the fuel mix that one adopts, and obviously that's the direction we're heading in, going from coal to natural gas, and then hopefully finally to hydrogen. The second point, though, about improving efficiency, that's really on the demand side. So in answer to your question, it actually works on both sides. You can only really reduce the efficiency by looking at the demand side management of buildings. In terms of the overall targets, whether they can be met, I do agree they're very ambitious targets that the government has set, but I do believe that it's good to set ambitious targets because that's the only way you're going to get people motivated to achieve better than they possibly would otherwise. So I do agree with it, but I do believe they're quite ambitious targets, and I do believe that it's quite difficult for the government to enforce some of these changes, particularly because of the differences between sort of government building demands as well as public building demands without suitable legislation. And then there comes the question at the end as to who pays for these changes if that was the direction that the government required the energy supply to go into.
Very good, Peter. So at least we have 30 years to plan, and I probably won't be here in the next 30 years, but hopefully you would guide us to and lead us to make sure that this happens. Sure. Thank you. Now, I see a question from the floor, and I'm going to read it briefly, and I'll ask TK to answer. Because, TK, you run the largest power utility in Hong Kong, and reliability to us is most important. The question says that COP26 is likely to be held with a backdrop of the oil price being at a peak for recent years and energy crisis being reported through the world. What are your plans for ensuring the energy security and reliability in the process of decarbonization? In particular, as the global supply chain is more fragile and mainland China these days also has its own energy crunch, what are the plans of the energy companies in Hong Kong to maintain the current level of service to the society? No.
Yeah, thank you, Edmund, and also thank you very much for the question. I think this is really a very good question. Hong Kong being a very congested, metropolitan city, reliable supply of electricity is of utmost importance because it's not only related to the so-called convenience of our daily life, but also to the safety and also I would even call it survival, our people, in a city. So in order to ensure that we have really reliable supply of electricity, we do need to have a very good long-term planning because energy and also electricity business is a very long-term business. All the investment are long-lived and also we take a long lead time in order to build all the assets. So we have to have good planning, we have to have long-term planning. Secondly, we also need to have very good design standards. We need to cater for possible contingency when we operate the system so that we can cater for those kind of emergency situations. Thirdly, I think keeping a more diversified portfolio from different kinds of energy sources would also help ensure our reliability. So if we look at the roadmap that I just mentioned, now in the near term, we use natural gas to replace coal so as to reduce carbon. And with CCGT being I would say a very mature technology, we can really control our generation, our power system in a nice way. But then when we introduce more renewable energy is an intermittent energy. So we need to make sure that we can really balance the intermittency, for example, by means of energy storage. And then at the same time, we also need to decide where those renewable energy comes from. And in terms of zero carbon energy, apart from renewable energy, I think nuclear should not be ruled out. Actually, if we look at the successful history or experience of our Taipei nuclear power station, in the design, we have already taken into account sufficient redundancy so that during very extreme situation, we can still maintain the reliable supply of electricity. And nuclear energy is a more controllable energy. And from a diversification point of view, if we have renewable energy, nuclear energy, and also because they are maybe coming from somewhere outside Hong Kong, so we should also consider local generation capacity. If you look at all the other major cities in other countries, normally they will keep certain amount of generation within the city themselves. And in Hong Kong, we are now using kind of transitioning to gas. And as other speakers has already mentioned, for example, in future, if hydrogen becomes more mature, we can reposition our generation fleet to burn hydrogen so that we can maintain a certain amount of local generation, so that we have this kind of diversified energy sources, both in terms of energy type and also geographically, so that we can have a more reliable system.
Very good, very good. Now, pursuing the subject of reliability, and I'm looking at Charles. Charles, I know you are most successful, not only in Hong Kong, but also in UK and Australia. And that's a very good example. On this matter of reliability, I heard that Power Asset had significantly improved the reliability of power supply for UK consumers over the years. Can you share with us some of your experience so you could educate us, please?
I'll give you a few facts, and it's actually a very interesting and educational. We took over the UK distribution network in October 2010. I remember walking into the CEO's office asking him what's keeping you up at night. And he said, it's the customers without power supply for more than 18 hours. At that point in time, it was more than 2,000. 6 months later, same crew, same management, same equipment, I walked into his office and I asked him, how many customers are without power for more than 18 hours? He said 200, 1/10. The following Christmas, I walked into the office, I asked him, Basil, how many customers are without power for more than 18 hours? He looked at the chart, he said 0. And I think if you can channel every employer's attention to one single problem and ask them to focus on it, you can actually make a big difference. And in fact, that's exactly what we've done. It's a lesson for me too, how important a CEO is to a company.
Excellent. I'll come back to you about these oil and coal crisis later if we have time. Now, can I turn to Alfred now? Mm-hmm. Alfred is a very humble business person. Most of you do not know he's actually in the top 100 of the Harvard Business Review most successful business leaders for many years. But I was going to ask him that question, but he avoided answer, so I'm going to ask him a technical question. I see here 2 questions on hydrogen matters, and I'm also interested in the growth of hydrogen economy. But I'll read these 2 questions from the audience so that you can answer them together, if you wouldn't mind, Alfred, because hydrogen economy is new in Hong Kong and you won't be stepping over the toes of your 2 friends here. One question says, if hydrogen is considered to be a more viable method of energy generation as constrained by the geography, how will this be produced in a green manner in Hong Kong? And the next question is, how will hydrogen be extracted and transported Is it green? And if not, can the emission be offset by the savings due to the clean combustion? Over to you, Alfred.
Okay. Thank you, Edmund. I think for the first questions about the production of green hydrogen has been answered by the two chief executives of the power companies. They are basically looking for Hong Kong, and also Peter has already mentioned it will be offshore wind farm nearby and generating power, and for the excess power for storage, then it can be using electrolysis of water to produce hydrogen and then store it for use. Whether it's used for peak hours to power generation or used for other purposes is another matter. And this actually is the point I want to make, is that hydrogen economy is considered as the ultimate kind of renewables for the whole world to look into for decades to come, provided that it's economical and its supply is abundant enough. Now, then, in Hong Kong, we have to get prepared for the use of hydrogen. And use of hydrogen you can put into two parts. One is the utilization of hydrogen, whether it's green, blue, or gray. You try to utilize the hydrogen first, if it's available. And then we look into how to produce the hydrogen in a greener manner. For my company, Tsai Gas, as I have shown in the PowerPoint before, that our gas actually contains 49% hydrogen in terms of composition. It's in the process of cracking, reforming of natural gas, naphtha, and also landfill gas, together with steam. So it's hydrogen-rich gas. So that means our infrastructure, including the pipeline, can support the use of hydrogen, because a lot of countries are very concerned about using hydrogen in steel pipes and so on. We have that experience there. So there's no problem in distributing hydrogen in our network. Then number two is that where should we be using the hydrogen first? Utilization. And our point of view is that for Hong Kong, as far as power consumption is concerned, the number one will be the power companies, and the second one will be in the transportation. In the transportation side, there will be road transportation, marine transportation, and also rail as well. And we actually have been talking very closely to 3 French house bus companies to utilize hydrogen extracted from our pipeline to be used in their fuel cell propelled buses. And they are very, very active in doing that. And it's very well supported by the Environment Bureau on that as well. And on the marine side, in fact, the government has got planned to build 6 new marine vessels to transport the garbage from Taiwan to Longgutan, for example. And those marine vessels will be using hydrogen as well, fuel cell. So we will be able to extract the hydrogen in Taiwan for them to be used in the marine vessels when they are available here. And also, in coupling with these feed vehicles, like the garbage collection trucks, they can use hydrogen fuel cell as well. So we are also doing experimental work on the extraction of hydrogen and use the hydrogen produced to do a little bit of power generation for experimental side in our typo plant using PEM fuel cell and also SOFC. So this will be a very exciting program for us as far as the utilization is concerned. As far as production of green hydrogen is concerned, our focus is in China because there will be sufficient agricultural waste for us to use using our own developed process, which has gone through R&D stage and has shown a lot of success. And we are planning to build a pilot plant within the next couple of years in China to produce green hydrogen from agricultural waste. So this will be very exciting. Utilization in Hong Kong using our pipeline will be fine. In China, using our pipeline can at least hold 20% of blended hydrogen into natural gas. And in Hong Kong, it's more than 50% we can do that. So there's a lot of work we are doing in Hong Kong and China, looking into utilization and also production of green hydrogen as well.
Very
Okay,
good,
thank
thank you. Charles, I think you have some experience in producing hydrogen in UK. Can you give a short supplement?
Yes, in Australia right now, actually, what we're doing is we're capitalizing on the excess solar in the daytime and excess wind at night, and we convert that through a electrolyzer into hydrogen, into green hydrogen, and then we blend it into the existing gas pipeline at 5%. In UK, what we're doing is we have actually research center. We call it a combined transport, home heating, power generation area, so that we can learn how we can use an even larger electrolyzer and drive the price down. The major thing right now is really on the pricing, how fast we can drive down the supply cost of hydrogen, and in particularly green hydrogen.
So the audience, you're happy to hear that the technical issues are mainly dealt with. It is the commercialization that we need to look at carefully. Let me switch to Peter. That's a very interesting question for you, Peter. It says, thanks for the presentation, which is good in pointing out that we are short in natural resources. Would it be possible to utilize by borrowing the land in Shenzhen rural area to generate solar energy for Hong Kong? If yes, how big would that area be?
Okay. Thank you. That's quite a difficult question, quite a political question to answer.
That's why I ask you.
No, as I pointed out in my presentation, the problem with Hong Kong is available space, and any space that we do have, we will use for housing, because that's the bigger issue at the moment in Hong Kong, and you wouldn't use that space to build solar farms. So if you did have an extension into the sort of Shenzhen rural area, then certainly, yes, that would help. It would allow you to develop solar farms, but I think, again, you know, whether or not that rural area or whether it should be used for other purposes is a political decision. And also you need to look at the resources. As I mentioned, in Hong Kong, the sunshine is really only around 3 or so hours per day. I think the same would be in Shenzhen. So in terms of the overall efficiency of that solar wind farm or solar farm, I'm not sure that it would be a solution, but it would certainly help in bringing renewables to Hong Kong. So I'm not against the idea, but I don't think it's the overall solution. I think the idea would be better to be looking at other areas, maybe in China, and bringing the power in from those locations where you have more area to utilize.
Thank you, Peter. I see an interesting question I'm going to ask our utility peoples in Hong Kong. The question is, in terms of reducing supply-side carbon emission for Hong Kong and East Asia in general, what is the number one thing that keeps you up at night? I bet nothing keeps you up at night, but if you have any views you want to share with us?
Maybe I'll try to...
Please, TK.
Give you my view. I think, as I said, I think electricity infrastructure is a very capital-intensive and long lead time projects. So we have to have government support.
Support, yes.
Yeah, in terms of there would be a lot of...
And they keep you waking up at night?
No, I think it's a matter of time.
Yes.
Because, as I said in the beginning, actually this issue is very imminent. And although we are talking about 2050, it sounds like a very long period of time. But for example, for cross-border infrastructure projects, I think minimum we need 10, 15 years So I think time would be something that I really feel that we really need to act very fast.
So speed is the essence. Charles and Alfred, any views you'd like to offer, or nothing keeps you up at night?
It does keep me up at night. I think what we'll do in Hong Kong is we'll try to maximize as much as we can in terms of renewable resources. Then we will look into, in fact, we are investigating as to whether or not we can burn hydrogen on our gas turbines, whether we should be burning ammonia, etc. All of these are options that we're exploring right now. And TK is right, it does take time. It's something that we want to do prudently and successfully.
Yeah, on this question, I have to be very humble because town gas, in terms of production side, generates about 1% of total carbon emission in Hong Kong. So it's very little.
So we can't blame you for that.
And even including the customer use side is about 4%. So it's very, very small. So any effort to further reduce it may not have a bigger return than looking at the bigger picture. But we also have to look into the demand side as well. I think demand side is important. If you have good energy management, then you have to reduce 10%, 20% of the energy consumption. Then obviously you will have to reduce the equivalent proportion of carbon emission as well. So what keeps me awake in the night is not a nightmare, but excitement.
Excitement, yes.
There are possibilities to reduce
opportunities, yes,
to reduce energy consumption for the same usage. For example, in Hong Kong, the biggest power consumption is on the buildings, and basically the air conditioning is a major part of it.
Yes.
And if we can have to reduce the air conditioning power consumption, then it will be a lot of savings there as well. Then how would Chiang gas help or others help? We have a team which look into how to reduce humidity in the indoor air quality side, so as to extract or limit the amount of moisture coming into the building in the fresh air intake, so that the energy required to, actually the latent heat required to liquefy the moisture into water droplets will be reduced. And also, as the humidity is reduced within the indoor air side, then the comfort of human will be the same, even if the temperature, indoor air temperature is raised 1 or 2 degrees higher. Now that means you will reduce the temperature gradient between the indoor and outdoor. That will help to save a lot of power as well. So we are having a team which look into more detail in how we can achieve that. And this will not happen in many other parts of the world, because they may not have such a high humidity as Hong Kong, which is a subtropical area.
But
that is very specific for Hong Kong, and we hope that we will be able to provide a solution that keeps me awake.
Excellent. So nothing actually keeps you awake because of problem. Issues are keeping our chiefs awake because of opportunities. Yeah. Very good. Now, time flies when we're having fun. We're almost to the end, but I'd like to leave the most difficult question for Peter. The question is, what are your views on carbon sequestration? Should it be a potential means for diversifying the energy generation portfolio, Peter?
Obviously, carbon sequestration is obviously a good idea. It's an idea that's been battered around in many countries for many years, but there's always the problem of where to sequestrate that carbon. I've always had my eye on the Chiang gas fields. It's where we currently get the gas for CLP for their power plants, and obviously there's a a depletion that's ongoing there in that gas field. So if there was a means of doing carbon sequestration, then I think that would be the ideal place to be sending any carbon that was captured from the existing gas plant. So I do think that would be a good idea, but it is quite costly. And it needs to, I say it's only limited to that one gas field. There aren't any others I'm aware of around Hong Kong, and I don't think the geology generally in Hong Kong, other than these gas field areas, would be cost effective in terms of doing this. So while I think it's a good idea, I just think practically it's a challenge, and I think that's pretty much the case in most countries around the world where they tried to do this. They all recognise it's a good idea, but you do need to have that suitable geology and existing gas fields or depleted gas fields in order to be able to do this successfully.
Excellent. I think TK like to raise another point on energy efficiency. Can you explain that
thank you,
to
Edmund.
us? Yes.
Yeah, because so much about supply side, we discussed quite a lot, and I totally agree with some of the speaker that I think, and also the question just now that I think the demand side is also very important, and CLP has been doing a lot to help our customer to save energy, to introduce different kinds of measures, including even incentives to our customer to save energy. And if you look at the numbers that in the beginning you mentioned, majority of the carbon emission from power generation, but then a major part is also from transportation, right? So if we can have, for example, zero carbon electricity in future, and actually, we can help electrify the transport sector, and that would then help, basically reduce the carbon of transport sector in a more efficient and effective way. And similarly, actually, if we look at the different kind of usage, even including buildings, if we look at the total energy efficiency, we are also very eager to help our customer, for example, to switch from other kinds of fuel, to electricity in order to reduce the carbon emission. I think that's very. So we need to really to act together, jointly together, not only from the supplier side but also with our customer in order to achieve the common goal.
Very well said. Yeah. The whole picture is very important, big picture. Now, really, we are overrunning our program, and although I like to speak as long as possible and seek more views, I think we have to call this meeting to a stop. But before I stop, I think I should thank our four speakers for spending their time, spending their effort, explaining to us their successes, and also to give us some technical views of how Hong Kong could reduce carbon in future. And I see a bright future of Hong Kong in carbon reduction, and I think this climate action plan that Environment Bureau has set on us is achievable. So with that, I'd like to hand back to our MC for closing.
So many thanks to all speakers for sharing your valuable insights. As Edmund mentioned, we slightly overrun, but also I feel you could continue to educate and enlighten the audience for much longer. Thanks also to you, the audience. I hope you enjoyed this as much as I did. Now, please be reminded that the next session hosted by Hong Kong as part of the Race to Zero webinar series will be tomorrow from 4 to 5 p.m. Hong Kong time. During this session, we will go into more depth on the theme of nature-based solutions. Similar as today, we'll have an excellent panel of experts. So if you haven't registered yet, please do so through the event webpage. Hope to see you tomorrow, and bye for now. Thank you.